There are two strings, namely text and pattern. If we want to efficiently find whether this pattern appears in the text, for example, the pattern here can match the beginning of the text, although the second start match. So how do we use the program to automatically realize it? The easiest way is to compare them one by one. The first is the comparison between the first four in the text and the pattern. We start from the first one in comma and compare. All are A. Then the next one is all A. The next one is all A. And the last one is also A. An exact match is found. This is the first match. Next, move the pattern back one place. Start to compare each character again. First of all, still the first, then came second, and so on. A successful match was found again. Then we continue to move the pattern back one place and start the comparison, and so on, until the end. So is there a better way? Then let's start again. For example, at this time, the pattern is compared at this position. The first three are all A on both sides, only the last one is different. So next, the pattern needs to be shifted one bit to the right. But before that, isn't it the only one who looks at the first three matches? That is the substring of the pattern. If we use the information here, we can skip some comparisons. For another example, let's compare from the beginning. Assuming that 4 has already been compared, at this time the next one is different. We only look at the first 4, which is the prefix of the pattern. Whether we can calculate it in advance, we need to move the pattern back once. Obviously, it won't work. Move it back again, it still doesn't work. Move again, it's okay. Although we don't know the result of the text, but at least it is possible to match. It was completely impossible before, so it can be moved at least 3 times and start the comparison from the second B of the pattern. Let's promote it. First of all the matched fragments of the pattern. Then calculate the prefix and the suffix of each fragment. The first A has neither a prefix nor a suffix. In the second line, AB, the prefix is A and the suffix is B. Next, the prefix of ABC is AB, and the suffix is CBC. By analogy, we can calculate the prefix and the suffix of all fragments. Next, we look for the common part of the prefix and the suffix. For the first row and the second row, neither. Then there is no third line either. In the fourth row, there is an A. The total length is 1. Next, there are a total of AB, and the length is 2. In the end, it didn't. Well, we only need to remember this table. Let's go back to the situation just now. First, A is aligned, and BCA is aligned. As a result, C and B are not aligned. Then ABCA has been matched, and the common one can be obtained by looking up the table. Therefore, if there is a complete mismatch, you can move 4 to the right, and now you can move 1 to the left. That is to move 3 to the right. Then continue to compare. B and C are not the same. Now, what is in comma is A. There is no comma part, and it is completely removed. Then C and A are not the same. Move directly to the right. Then only A is matched, and the lookup table is still 0. So continue. By analogy, obviously the text has no matching pattern. So in general, the original model needs to be compared one by one until here, but now it can be done directly in one step, saving a lot of comparison times. Alright, this video is over here and we will see you in the next issue.